So good evening, everyone. I'm Calvin Joseph, and I'm going to conduct your problem solving and doubt clearing session for week 2 for this course. So today we will be doing the week 2. So we will have a recap of what Sir has taught, and then we will proceed further. So one thing is, Sir has considered is an ammeter. So ideally, what should be the internal resistance of the ammeter? So ideally, the ammeter's internal resistance RA should tend to 0. It should be as low as possible. That is desirable. And there are various instruments which are as described in the previous week, which can be used as ammeters. So for example, there's a moving iron can be used as an ammeter. The electrodynamic instruments also can be used directly as an ammeter to measure current, as well as the permanent magnet moving coil. PMMC instrument is used. Okay, so these things have been described in week 1. So now we will just be looking at the concept of an ammeter. Like we require an ammeter to measure current, and there are certain things we have to consider about the ammeter. So suppose, so one part of an ammeter is we don't want an ammeter to change the current flowing previously in a circuit. So suppose your circuit is like this. Say this was your circuit and you want to measure this current I. So what do you do is, you will have this R1, this R2, your ammeter like this over here, plus minus V, and your R3. Now you want to check what is the current. You will see through the ammeter's deflection. So if your ammeter shows, so your ammeter has a scale, it will have like these pointers, etc. This may be 0, suppose 10, 20, 30, 40, 50, all in milliampere scale. So depending if it is showing here, you will assume that the current was 30 milliampere in the ammeter. And that was the current I flowing. But there might be an internal resistance RA of the ammeter may be finite. It may not be 0. It may be some finite value. And when it is finite, what will happen? This current, suppose I original, and this I ammeter. So because the resistance of the ammeter is finite, it might occur that the I original is not equal to the current which is seen by the ammeter. Okay, so there's this problem with the ammeter that it might change what it is supposed to measure. So in any sort of any field, in any engineering branch as such, measurement, when we take measurements, what we want is that the measuring instrument should accurately be able to measure what it is, what quantity it is going to measure, and it should not cause any alteration or change to that quantity when that measuring instrument is added or brought close by. Okay, so that is desirable, but that that won't always happen. So in that case, what we want to do is we want to minimize the effect, like the error which might occur. So we have to choose an instrument in such a manner that the consequences of it being added in the circuit is minimal. Okay, so those things we will have to see. Now another part which Sir has taught is, suppose you have a PMMC instrument. Okay, you have a PMMC instrument and it can read, there's something known as full scale deflection. Okay, so if you see this scale that starts from 0, 10, 20, 30, 40, 50. So your I full scale deflection of this particular ammeter is 50 milliampere. So once you see that your ammeter is rated only for 50 milliampere, you must connect it in a circuit and you must make sure that the current, maximum current which can flow through the ammeter is only 50 milliampere. Okay. But now in various practical circuits which we have, in the circuits which you will make, etc., it may not be that only 50 milliampere current is flowing. There might be more current that is flowing. So when there is more current flowing and you only have this ammeter instrument, then what can you do? Okay, what you want to do is you want to increase the range of your instrument. So to do that, you have to effectively increase the full scale deflection of your instrument. But now your ammeter is made. Okay, you have made the ammeter instrument is with you and you cannot change it. You cannot alter it. So you have to find a workaround to it. So what they do is, suppose there's an PMMC instrument or ammeter, we add a shunt resistance or shunt parallel. So this can carry current maximum IFSD, but this is the current through the shunt. Okay, and this is your total current I. So what happens is this entire thing becomes my new ammeter or my overall ammeter box. Okay, and depending on if it shows, suppose it shows 50, like this earlier it had the full scale deflection of 50 milliampere. Then we connected our shunt, and then we change this I max could then become equal to say 500 milliampere. Okay. So now if we know that my deflection is showing 50 milliampere, it means the current I is actually 500 milliampere. So we found a ratio. Okay, we found a ratio, we found a mapping which we can use, right? So, um, so now what Sir has taught is how do you select the shunt resistance, R shunt for this. So what is flowing through this IFSD is 50 milliampere. The current flowing over here has to be 450 milliampere because the current over here is 500 milliampere. Okay, also let us assume that your RA of your meter is approximately 10 ohm. Okay, it is 10 ohm, RA is 10 ohm. So then this drop, this voltage drop over here is equal to I full scale deflection into RA. So this voltage drop is actually 50 milliampere. So 15 to 10 to the power minus 3 into 10. So that is 0.5 volt. Huh? Now your current I shunt into R shunt, they also have the same voltage drop V. So your I shunt will be equal to V upon R shunt. Alright. But we already know I shunt. We don't know R shunt. So we have to write my R shunt is equal to V upon I shunt. That is equal to 0.5 upon I shunt. That is 450 milliampere. That is equal to 0.5 divided by 0.45. So can you calculate and tell me what is this? What is 0.5 divided by 0.45? Yeah, you're right, Manchini. It comes out to be 1.11 ohm. Okay. So in this manner, we can change the range of the ammeter. So what we have effectively done is we have changed the range of the ammeter. We have modified it, we have increased it. So if we want to have further ranges, what we would need is we would have this ammeter with full scale deflection of 50 milliampere. Then we'll have R shunt 1, R shunt 2, R shunt 3, etc. And there's this terminal, okay, just connected over here. So we will have a switch. So it can either be at this position, or it could move to this position or this position. So these will have different ranges. Say if I connect it to R shunt 1, the range can be 500 milliampere. If I connect it to R shunt 2, the range can be made to 5 ampere. If I connect it to R shunt 3, the range can be made to 50 ampere. Okay. So in this way, I can have a multi-range ammeter. Okay. Hmm. So does anyone have any doubts till now? Vanchini and Mutaz Zari, any doubts? So whatever doubts and queries you have, if I made a mistake, okay, you can unmute and tell me, or you can either put it on the chat also. I'll respond to it. Right? So now we can also have what is known as a voltmeter. So the objective of the voltmeter is to measure the voltage. You have to use it to measure the voltage in a circuit. So I assume you guys or girls are from engineering colleges or have done your engineering, etc. So you would have had experiments where you have to connect rheostats, ammeters, voltmeters, etc. So when you are doing a particular experiment, when you're making a circuit, first you will be given what is known as a circuit diagram. Okay, you will be given a circuit diagram in the lab. At least this is what we used to do. So we will be given a circuit diagram, and they will tell us you must connect this circuit and you must keep. So there may be some rheostat, there may be some transformer might be there, etc. Okay, or there might be a motor might be there. All right. So we have effectively what do we have is we have an electrical circuit, and in the electrical circuit we also have to connect these ammeters, voltmeters to measure certain quantities. So when we will make the connections, what we do is first we will first assemble that. We will keep the rheostat, we will see the transformers here, we will bring it here, we will get the wires, etc. We will cut it and clip it, and remove the insulation of the wires such that we can make connections. All that we will connect, and then you must connect your ammeter also. The ammeter also has to be connected. And the last part, like the last equipment which you will connect is your voltmeter. And the reason for that is the voltmeter is actually connected in parallel. Okay. So first you connect your circuit, okay, with the ammeter, wattmeter, etc. And then at the end you connect the voltmeter. And when you are doing those experiments, there will be say certain ranges that they will say your ammeter should be of the range 0 to 5 ampere, or say 0 to 10 ampere, etc. Huh? And then in the practical ammeter which you will have, there will be one knob. Okay, that is your common point. Then there will be another which stands rating for 5 ampere. Another will have rating for 15 ampere. Another will have rating for 30 ampere. Okay. So this is how the block is. So if I want to use 5 ampere, I will connect the wires like this. Okay. And if I want to use, if I want to use the 15 ampere one, I will connect the wire like this. Okay. So this is how I can measure the current. Now, but in all these instruments, if you will notice, this is sorry. So if you would see those measuring instruments, oh, they'll have some scale. Okay. So say this is so 0, 1, 2, 3, 4, 5. It will have one scale. So now if I am using a 50, and these are all in ampere, okay, if I'm this is in ampere. So if I'm using a 15 ampere current, so if there's suppose I'm using the 5 ampere scale, then it is showing my pointer is showing over here. If my pointer is showing over here, I know that my current is 3.5 ampere. But if I'm using the 15 ampere range and it is pointing over here, means I will know that it will be 3.5 into 3. What is 3.5 into 3? Can you calculate and tell? Yeah, it is 10.5. So I will know it is 10.5. So there could be two cases, okay? There could be a case that there is only one scale. There could be a case that there's only one scale, or there could be a case when there's multiple scales. So there could be where it is written 0 and 5 ampere. It could also be written 0 and 3, 6, 9, 12, 15. Both can be written. So then you will know that if it is showing at this point and I have connected in 15 ampere rating, means it is actually pointing to 10.5 ampere. If I've connected it in the 5 ampere socket, then it is actually showing 3.5 ampere. So depending on which terminal you connect, you will know what is the range of your ammeter. Okay, similarly, it can be for your voltmeter also. Okay, so these ammeter and voltmeter are the very standard measuring instruments which you will use. Okay, and for a voltmeter, you want, okay, Sanjay, please don't write or scribble anything. Please rub it off. Sanjay, yeah, please remove whatever you have written. Like this yellow line has come. How has it come? Are you not able to remove it or what? So is the yellow line seen for others also? Mutsagi is Vanchini, because there's this yellow line on my screen which I'm not able to rub. Okay, okay, I've removed it. Okay. Okay, so now we have what is known as a voltmeter. Okay, a voltmeter, its impedance should be infinite. Okay, effectively we want impedance of a voltmeter to be infinite. And why do we want that? For what reason we want the impedance of a voltmeter to be infinite? So in some circuit, I have connected my voltmeter. Okay. Now I want the current which is going into my voltmeter to be 0. Then only this original voltage which was shown here, some V1 voltage which was there, will remain the same. Okay, if the current is not 0, then V1 will change. Okay, so we would want my RV to be infinite. In practical reality, it is not infinite, but if the effective resistance RV is much greater than the Norton equivalent of the resistance between these 2 points, between the point A and B, then we can say that the voltmeter will be quite accurate and it will not load the circuit. It will not create any error, right? Okay, so anyone has any doubts, any questions till now, you may please ask. So now we can check um, how do we extend the range of a voltmeter. Assume there is a voltmeter, okay? It has its own internal resistance RV. Let us say RV is 10 kilo ohm, okay? And the voltage range which it can measure is 0 to 100 volt, okay? So now this is the rating of my instrument, rating of the voltmeter which I currently have. Now I want to increase that rating. So you must understand that there is a current I which is flowing through the voltmeter. Okay, there is some current at least which is flowing. So this voltage which it can measure V, this voltage is actually uh, I into RV. So now my I want to know how much is that current. So that is equal to 100 divided by 10 kilo ohm. So that is 100 divided by 10 into 10 to the power 3. That is equal to 0.01 ampere. So that maximum current that can flow through this device is 0.01 ampere. But then now what I want to do, I want to change the device to measure 0 to 400 volt. But then the maximum current that can flow will be 0.01 ampere alone. It cannot increase. So what is done in such a case is, this is the instrument. It has a full scale deflection of 0.01 ampere. It has this RV of this, and then we add an external resistance RS in series. And then this will measure the effective voltage V new. Okay. So we want my V new should be equal to 400 volt. Okay. And the current that can flow max is still 0.01 ampere. That is why RV plus RS is equal to V new divided by I max. Okay. That is equal to 400 upon 0.01. That is equal to 400 0. So how much is that in kilo ohm? Can anyone tell me? There's so many of you guys here. Sanjay is there. CS Sanjay is there. Mutaz Shadi is there. Vanchini. How much this is in kilo ohm? Yeah, it is 40K. Okay, it is 40K. But we know my RV is already 10K. So my RS, we already know that RV is equal to 10K. So my RS will be equal to 30 kilo ohm. Okay, in this way I know that if I place a resistance of 30 kilo ohm in series with the voltmeter, then I can effectively extend the effective voltage that is measured across this new terminals of the voltmeter. All right. Okay. So Sanjeev, please don't use annotation because that is what is causing the issue. Sanjeev, please don't do that. If you have any doubt, you can tell. So in this way, we have extended the range of the voltmeter. And if we uh, also, I have to tell a certain thing is that this meeting will only be for 40 minutes and then this Zoom meeting will end. Okay, so then in that case, I will actually restart this meeting. Huh. I will actually restart this meeting and then you may join on the same link, right? So in 10 minutes it will end. So that time I will, after the meeting ends, I will again restart it. And one more point, which I'd like to share the links. So all these lectures, they will be sent. So these notes which I'm preparing, they'll be uploaded in this drive link which I've added here. So you may go to this link and you will find these notes which I'm writing right now. You will find it there. So in the class also, you may follow it. And after the class also, there will be a record which you can check for your reference. It will be there. Also, these sessions will also be uploaded on YouTube. Uh, so that link also I will share. So this is the link. If you guys are able to see the link, there's a link to my YouTube channel. So you may go there and when I finish, merging, editing this video, I will upload it on YouTube and you may refer to this later as you require for your needs. So I try in my sessions, what I'm trying to do is I'm trying to do a recap. So the important details of the week, the important things which you must consider while solving sums, you may have that knowledge. So once you have those important recap, then we will go to solving the previous year assignment, and then you'll be able to be confident enough to solve the assignments as well as the other things. I know you guys are smart. I know you guys are able to solve assignments, but in these sessions, you may ask your doubts, whatever doubts you're having in the course material, as well as whatever doubts you are getting while trying to understand the concepts, okay, or the reason why you're doing it, okay, then you may ask those doubts as well. And uh, I don't know the exact reason why you guys are doing this course. Is it for gate preparation or is it for your course, your college that you need some credits for that reason? Or what is the scenario? I don't know. If you could tell me, and accordingly, you can see what is useful for you all. Okay, so in this way, we have learned how to increase range, the range of a voltmeter. Okay, then we could also use an ohm meter. Okay, an ohm meter also is an instrument which we want. Okay, so what do we do is if we want to measure the resistance, okay, we want to measure the resistance, right? So we know how much is the current flowing, current flowing we can measure using a PMMC instrument, etc. We can measure, and we also know the resistance. Sorry. Okay. So what we do is,
सर ये RV लिखे हैं, RV बराबर 10 किलो ओम।
हाँ RV 10 किलो।
अच्छा RV मतलब ये
हाँ बोलो।
ठीक, जी 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 सर, ये अभी सर हम लोग ड्यूटी अवे किए हैं ना, इसीलिए सर दिक्कत है।
क्या हुआ क्या हुआ?
अभी सर ड्यूटी से जस्ट करके आए हैं ऑफिस से।
अच्छा 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 अच्छा, ठीक है। ओके
इसीलिए लेट ज्वाइन करना पड़ा सर।
अच्छा अच्छा।
सर
आपको, आप कौन सा ऑफिस पे काम करते हो वैसे?
सर हम लोग सेल में हैं, बोकारो स्टील प्लांट।
ओके ओके, अच्छा ठीक है। एक्चुअली ये सेशन यूजुअली 6 से 8 बजे होता है मंडे को, वो शेड्यूल टाइम है। पर
जी सर।
नेक्स्ट वीक मेरा कॉन्फ्रेंस है, इसलिए मैं थोड़ा नेक्स्ट वीक में बाहर हूँ, इसलिए मैं अभी
जी सर,
ये टाइम
जनरल
पे
शिफ्ट
डाला
में।
था। हाँ
जी जी कोई बात नहीं सर।
वही, ठीक है। ओके।
ये R0+RS है सर।
किधर? हाँ
R0+RS भी वोल्टेज न्यू बटे आई मैक्स मैक्सिमम।
हाँ, क्योंकि ये वोल्टेज न्यू इज इक्वल टू आई
जी
मैक्सिमम इंटू आर
जी
वी प्लस आर एस, ठीक है।
अच्छा ठीक जी। आर भी मतलब सर?
आर वी है वो वोल्ट मीटर का रेसिस्टेंस, इंटरनल रेसिस्टेंस। फिर
जी ठीक है सर।
उसके सीरीज में हम लोग और एक रेसिस्टेंस लगा देते हैं।
जी ओके सर ओके।
So if you want to measure resistance, you want to know how much is the resistance, what you can do is you can connect an ammeter and you connect a voltmeter and you have your resistance and you have some particular voltage source. Okay, so you will know what is the current flowing and what is the voltage across the voltmeter, and your resistance estimate will be your voltage upon current. Okay, this is in the ideal scenario, right? This is in the ideal scenario where you will assume that your voltmeter is ideal, that is the voltmeter resistance RV is infinity, your ammeter current RA is, the resistance is 0. In this case your reading will be accurate, but that is not always the case. Okay, so there are two types of configurations. It can be either in this form or it could be in this form. You have voltmeter here. No, I'm sorry. You have a voltmeter over here. You have an ammeter here, and then you have a resistor. This ammeter measures the actual current flowing through your resistor. Okay, and here and there's some voltage VR across your resistor, but there will also be some drop across your ammeter. Okay, so your voltmeter will measure VA, the voltage across the ammeter, plus VR. Okay, so if VA tends to 0, then it is fine. So this will happen only when your resistance, this resistance to be measured, is much greater than RA. Okay, when the resistance to be measured is much greater than the resistance of the ammeter, then this circuit will have less error. Then the circuit measurement will have less error. And in the previous case, in this connection, what is happening is this current to the ammeter is getting divided. It is getting divided into IR and into some IV. So we want IV to be low. Okay, ideally IV should be 0, but it is not. But in this case, it will be negligible in comparison to IR if your resistance of your voltmeter is much greater than the resistance to be measured. Okay. So in this way, we can either of these two circuits we can use depending on the on a range of the resistance which you want to measure. Okay. So in this way, you can measure the resistance. Further, there is another way. So we know PMMC instrument. PMMC instrument. This can only measure DC. It can only measure DC. But what if we have an AC quantity? What if we have an AC quantity that we want to measure? But we only have a PMMC instrument. So what we have to do then? In that case, this AC quantity has to be converted into a DC quantity. And then the PMMC instrument will measure. It can be used for measurement and it will give you the readings which you require. Okay. So say you have a sine wave. Okay, this is a sine wave. Okay. Now this sine wave has to be converted into a DC quantity. Okay, you want to convert it in DC quantities. So assume this maximum is A. You place a full bridge rectifier and it gets converted like this. Like this, like this, like this. Okay, all with the magnitude A. This is time, this is time. Okay. So once you convert it into this DC quantity, into this pulsating DC, then you can send this to a PMMC and it will measure the average of this. Okay, it will measure the average of this. It will measure the average. So in this way, we can convert it. And how do we convert is there's a bridge. Okay. So when this is positive, positive, what happens is current will go like this. It will flow like this, flow like this, flow like this, and come here. Okay. When the current is negative, when the voltage is negative, that means this is negative, this is positive. Then current will go like this. It will flow like this. It will flow like this, flow like this, and come here. So what is happening is, if you see this instrument, which is the DC thing, current is always flowing like this. Okay. It is either flowing like this or current is flowing still like this in both positive as well as in negative. So this is why it is in positive cycle. This is why uh, it is in negative cycle. So in this way, we have this very simple configuration of diodes which can generate a DC quantity from an AC quantity. Okay, so that is the beauty of that. And then whatever DC quantity is generated, it goes to your PMMC instrument. And that, because it is able to measure DC quantity, it is able to generate the average value of that. Okay, so in that way, you can, once you know this average value, you can also know this. Once you know this, you also know this. And once you know this, you can know the RMS value of the AC quantity. Okay, so we will check some sums. All right. So till here, does anyone have any doubt?
No, sir.
Okay. Yes. So let me start with the problems. Let's go to a new page. There's a question. Okay. So there is circuit 1, circuit 2, circuit 3. Circuit 1, circuit 2, circuit 3. Okay. They have told voltmeter reading is 420 volt, ammeter reading is 4 ampere. So let us consider circuit 1. What we will do is we will replace circuit 1 as V. This is your voltmeter, right? It has its own internal resistance RV. Okay, this is your ammeter. It has its own internal resistance RA. Then this is my Rx. Okay, what do I know? What do I know? What information I have is this voltage is equal to 420 volt and this current is equal to 4 ampere. Okay, so now what can I write? I can write my 420 is equal to I into RA plus Rx. So 420 is equal to 4 into RA plus Rx. So what is 420 divided by 4? Can anyone tell me?
210. 210, sir.
420 divided by 4.
Oh, sorry. Yep. 105.
Yes. So 105 is equal to RA plus Rx. This is my equation 1. Okay. That's it. So Vanchini and Mutaz Hagi, were you facing any issue joining? Was there any problem while joining? Because the meeting ended long ago and then I again started. So was there any issue or
No, sir.
no? Okay, okay. That's
Oh,
it. Mhm. Okay, so I have actually started solving sums. So now this we use circuit 1 and we found out some relation of RA and Rx we found out. Now we are to use circuit 2. Okay, we will use circuit 2. So I will replace circuit 2 by its equivalent resistance and everything. Okay. So this is my ammeter. It has this resistance RA. This is my voltmeter. It has its resistance RV. And this is my Rx. Okay, this is my Rx. Right? This is for circuit 2. Okay. Now what do I know is my ammeter is reading 3 ampere, my voltmeter is reading 273 volt. Okay. So this is reading 273 and this is reading 3 ampere. So now what is happening? It is getting divided over here and over here. So this current 3 is getting divided as V upon RV plus V upon Rx. So that is 3 is equal to 273 divided by RV plus 273 divided by Rx. Okay. So what is 3 divided by 273? So I can also write this as 3 upon 273 is equal to 1 upon Rv plus 1 upon Rx. So 1 upon Rv plus 1 upon Rx is equal to 1 upon 91. Right?
Yes. Okay, sir.
This is my second equation. And this I got from circuit 2. So now I must go to my circuit 3. So you must understand you have 3 unknowns. You have to find Rx, Ra, and Rv, all in all. We have 3 unknowns. Okay, and there are 3 circuits which enable you to get 3 equations so that you can solve for those 3 unknowns. Right? So now your circuit 3 is what? It is your ammeter followed by this Ra, and you have this voltmeter and RV. Okay, and this current I is actually given by 0.2 ampere and your voltmeter reading is 200 volt. So this is 0.2 ampere and your voltmeter reading which is showing is 200 volt. So what we know from here is your V is equal to I into RV. So that is equal to 200 is equal to 0.2 into RV. So your RV becomes equal to 1000 ohm, or your RV is equal to 1 kilo ohm. Okay. Any doubts over here?
Okay, sir.
So the main part you must understand is, although I'm replacing the voltmeter with a voltmeter and a RV, the drop which it is measuring is only across the voltmeter, right? The internal resistance of the ammeter is not coming into the picture. Okay. And the ammeter is actually measuring the current actually flowing through it. Okay. So what the ammeter is observing is the actual current in the circuit. Okay. So that is why we are able to get RV. So now once we have got RV is 1 kilo ohm, we can substitute it over here. Okay, we substitute it in equation here. So what we get, 1 upon 1000 plus 1 upon Rx is equal to 1 upon 91. Okay, so what is the answer? Who will tell me? What is Rx? Hello?
At 83.40.
Okay, so what did you get Rx to be?
83.40. No, sir, wrong, sir. Wrong. गलत है सर ये। गलत है सर।
Hello? So I am getting Rx to be equal to 100.11 ohm. Can you guys confirm?
Right, sir. Right, sir. 100.1100.
Okay, so now once I've got Rx is equal to 100.11 ohm, now what I will do is, I know this equation, right? This equation is that I got Rx, now I have to find Ra. So I have 105 is equal to Ra plus Rx. So my Ra is equal to 105 minus Rx. So what is my Ra? You guys should be able to tell me this at least. So many of you guys are here. Sanjay is there, Mutas, Ragi is there, Niranjan is there, Sanjeev Kumar is there, Vanchini is there. Please have your calculators with you and please solve and tell me what will be RA.
4.89. 4.89. No.
You may also type it in the chat once you finish solving it. Okay.
4.89 हो रहा है सर.
I'm not able to hear you guys. That's the issue. Are you guys able to hear me?
Yes, sir.
Okay, this 4.89. Yes, you're correct, Niranjan, 4.89. Correct.
सर 4.89 ओम हो रहा है. आधे बराबर.
So my R is 4.89 ohm. Right?
जी.
Yes.
So now we have solved this question. We found Rx, we found Rv, and we found Ra. Now we will go to another question. Okay. So now let us read this question. It is written a multi-range ammeter is made up with a PMMC instrument. So firstly, there is a PMMC instrument is there. It is having full scale deflection current. Current of full scale deflection is 50 milliampere. And the coil resistance Rm is 1000 ohm. There are three ranges. There's range 250 milliampere, 1250 milliampere, and 6250 milliampere. So you must identify the correct switch position for the above three ranges. So what should we do now? How will I proceed to solve this? So at position 1, there will be some configuration of resistances. Okay. So let us consider position 1. That is, this is this RM. It's coming over here. Coming over here. This is R1. This is coming to position. This is R2. This is R3. These all are connected. And this is like this. So effectively, your current is entering like this and going out like this. Your current is like this. So it is actually R1. Then here RM, R2, R3, like this. Okay. So what other information do I have? What information do I know? So they have told us that 50 milliampere is the maximum current. 50 milliampere. This is the maximum current that can flow through this galvanometer, through this PMMC instrument. Okay. And so whenever this comes in series with that, the maximum current that can flow through that PMMC instrument is 50 milliampere. So if RM is there, that means when we are doing our calculations, we must consider that the current flowing through that RM is 50 milliampere. So for sure, we know the current over here is 50 milliampere. We don't know the current here. Our current in position 1, we don't know. Okay, that is what we want to find out. Okay, so this is one part. Secondly, and we know what else can we say? We know 50 milliampere into Rm plus R2 plus R3 is equal to I1 into R1. So we don't know I1. We want to decide which current will be maximum. They have told us three ranges. They have told us 250 milliampere, 1250 milliampere, and 6250 milliampere, but we don't know which range corresponds to which position. So that we want to determine. So now let us try another position. So there is position 2. In position 2, what happens is this part gets connected. This part gets connected. Okay. So position 2, we have our this. There is this RM. R3 also comes. And this will become R1 and R2. Okay. So this is for position 2. So there is this current 50 milliampere flowing for sure over here. And we want to know what is this current I2. So this we don't know. Similarly for position 3, this gets connected over here. Okay. So for position 3, the circuit will become like this. It will just be Rm and R1 plus R2 plus R3. Just be Rm, R1, R2, R3. Okay. So this we know this is 50 milliampere. This is I3. Okay. So now we don't know which position will have maximum current. We don't know which position will have maximum current. So we know, but what do we know? We know the current through this branch is 50 milliampere. The current through this branch is 50 milliampere. The current through this branch is 50 milliampere. Now the current over here is the question. So, see. So now, let us say for this branch, let me do plus. By current division rule, we know current division rule, 50 milliampere is equal to I3. Sorry. We know 50 milliampere into Rm is equal to I3 minus 50 milliampere into R1 plus R2 plus R3. For position 2, it was 50 milliampere into Rm plus R3 is equal to I2 minus 50 milliampere into R1 plus R2. And in position 1, it is given by this equation. So now we want to know which will carry maximum current. So we know if this carries 50 milliampere, then R1 will carry some amount of current. In this case, it will carry 50 milliampere, but there will be more resistance to the current which will flow because R1 and R2 is coming in series. Since R1 and R2 is coming in series, there will be more resistance, so lesser current will flow. In this case, R1, R2 and R3 all are coming in series. So even further lesser current will flow. So at position 3, it will be the lowest current rating, that is 250 milliampere. In position 2, it will be the middle current rating, which is given by what? 1250 milliampere. That is given by 1250 milliampere. And at position 1, it will be given by 6250 milliampere. Okay. So that means if I want my instrument to measure 6250 milliampere, I must connect it to position 1. If I want my instrument to measure 1250 milliampere, I must connect it to position 2. And if I want it to measure 250 milliampere, I must connect it to position 3. Okay. So now we have sort of got the generalized idea, which through intuition we understood that through Rm, whichever branch is Rm, there 50 milliampere only will flow. And we checked in position 1 as well as in position 2 and position 3, the resistance in the other branch was increasing a lot. So if the resistance was increasing in it a lot, that means the effective current which will flow through it will reduce. And if the current that will flow through it will reduce, we understand that that is for the lower current rating. So that is why for position 3, it is 250 milliampere. For position 2, it is 1250 milliampere. And position 1, it is 6250 milliampere. So anyone has any queries in this?
No, sir.
Okay, so I'll proceed. So now we want to write the equations. So for position 3, this meeting will end in 10 minutes and then I will again restart this meeting after it ends. All right. So once it ends, you again rejoin, again click the link. I will let you in. All right. For position 3, we know Rm into 50 milliampere is I3 into R1 plus R2 plus R3. Okay, because there is a voltage over here. This voltage is what? This 50 milliampere into Rm or this R1 plus R2 plus R3. Okay. Achha. So we know I3 is actually 250 milliampere, the lowest current range. So the current over here should be 200 milliampere. So we replace this by 200 milliampere. So milliampere gets cut, 50 and 200 becomes 4. So we get Rm is equal to 4R1 plus 4R2 plus 4R3. This is our equation 1. Okay. Now for position 2, we have 50 milliampere and this is rated for 1250 milliampere. So this current over here will be 1200 milliampere. So that would be, so now let us consider for position 2, 50 milliampere into Rm plus R3 is equal to 1250 milliampere into R1 plus R2. The milliampere gets cut, 0 gets cut. 5 divided by 125 divided by 5 is how much? Is 25. So this is 25 into R1 plus R2. Okay. Now for position 3. No, for position 1. We are done for position 3. Now we have to do for position 1. So this current is 6250 milliampere. This current is 50 milliampere. So this current has to be 6200 milliampere. Okay.
Yes, sir.
That would mean 50 milliampere into Rm plus R3 plus R2 is equal to 6200 milliampere into R1. Milliampere gets cut, 0 and 0 gets cut. So Rm plus R3 plus R2 is equal to 1, 620 divided by 5. How much is 620 divided by 5?
124.
Is equal to 124 into R1. So this is our equation 3. So now how will we solve this? We have 3 equations. Rm is 4R1 plus 4R2 plus 4R3. Or Rm plus R3 is 25 into R1 plus R2. Or Rm plus R3 plus R2 is equal to 124 R1. So does anyone have any idea what should we do?
Equation को minus करना पड़ेगा सर. Equation 1 minus equation 3 और equation 2 minus 3. Then proceed.
So what I will do is, I will see that I know Rm, right? So what I will do over here, if I say my Rm is equal to 4 into R1 plus 4 into R2 plus 4 into R3, sorry. So I can write it as So I can write it as 4 into R1 plus R2 plus 4R3. So what I do is, I write my Rm minus 4R3 is equal to 4 into R1 plus R2. So now my R1 plus R2 is equal to Rm minus 4R3 divided by 4. I will substitute this equation 4 in equation 2. So what I will get is Rm plus R3 is equal to 25 into Rm minus 4R3 divided by 4. So that is 4Rm plus 4R3 is equal to 25Rm minus 100R3. So that would be 104 R3 is equal to 21 Rn. So my R3 will be equal to 21 into 1000 divided by 104. And how much is it?
Two hundred 1.92.
So that is equal to 201.92 ohm. Is everyone following, or is there any confusion here? Because you guys are not asking any questions. Okay, so now we got R3. Now what do we want to do is we want to find R2 and R1. So we will look for a way in which we can eliminate R3. We can eliminate either R1 or R2. Okay. So any suggestions? So what we will do is we will put equation 2, put 2 in 3. So we know Rm plus R3 is equal to, let me go to full screen. I know my Rm plus R3 is 25 R1 plus R2. So this is Rm plus R3 plus R2. So it is 25 R1 plus R2 plus R2 is equal to 124 R1. So the meeting will end in 1 minute, and then after that, I will again restart the meeting and you guys can join.
Okay,
So
sir.
this is 25 R1 plus 25 R2 plus R2 is equal to 124 R1. So we get 26 R2 is equal to 99 R1. Correct? So we got 26 R2 equal to 99 R1. So we can write it as 99 R1 minus 26 R2 is equal to 0. We also have, so this is our equation 5. We also have this equation that Rm is equal to 4 into R1 plus R2 plus 4R3, right? So we can write Rm is equal to 4 into R1 plus R2 plus 4R3. So that means 4R1 plus 4R2 is equal, okay, is equal to Rm minus 4R3. So R1 plus R2 is equal to Rm by 4 minus R3. So R1 plus R2, Rm is 1000. So 1000 divided by 4 will be 250. And R3 comes out to be 200. We found it to be 201.92. So we get R1 plus R2 is equal to 250 minus 201.92. So what is this? So R1 plus R2 comes out to be equal to 48.07 ohm. Okay. So this is equation 6. So what we have
08, sir.
48.08 or 07, both are almost equal. So now what we do is we substitute R1 or R2 over in equation 5. So we can write R2 is equal to 48.08 minus R1. This is equation 7. Equation 7 we put in equation 5. Instead of R2 we put it. So we write 99 R1 minus 26 R2, we write it as 48.08 minus R1 is equal to 0, right? So we have 99 R1, and what is 26 into 48.08? It comes out to be minus 1250 plus 26 R1 is equal to 0. So we get 99 plus 26 R1 is equal to 1250. So R1 into 125 is equal to 1250. Therefore, my R1 will be equal to 10 ohm. So if I found out my R1 is equal to 10 ohm, then my R2 is equal to 48.08 minus R1. So it is 48.08 minus 10. So that becomes equal to 38.08 ohm. All right. Any questions?
No, sir.
So basically we first had to understand, we first drew each position. Position will have this circuit diagram. Position 1 will have this circuit diagram. Position 2, this circuit diagram. Position 3, this circuit diagram. Then we found out through intuition. We know that through RM 50 milliampere only can flow. So that's why in position 1, the other branch has the least amount of resistance. So that should be the one carrying most current. So that is why the range of 6250 milliampere is assigned to position 1. Position 2 will have little lesser current. So it is given the range 1250 milliampere. Position 3 will have the least amount of current. So it is assigned the range 250 milliampere. Okay. Then we write their equations. We know the current 50 milliampere is flowing through here. So that means 6200 milliampere will flow over here. Okay. And we wrote those equations. Okay. And when we write the equations for each and everything, then we will get it in a form where we can, we will have 3 equations and we will have 3 unknowns. Because we know RM, we don't know R1, R2, R3. So once we solve those equations, then we will get the values of R1, R2, R3. Okay. So it is important for you guys to know how to solve it in this manner, to modify the equations so that you can solve. Because in your NPTEL exam, you will not have the scientific calculator. So you cannot say I have 3 equations, I will put their coefficients and then I will get the answer. That is not possible. In the scientific calculator which you use, you can do it. But in GATE exam or in the NPTEL exam, which uses the GATE calculator, you cannot do it. So you have to learn how you have to manipulate or move the equations, and how to arrange the variables in such a way that they can cancel out and you can get their values. Okay. So if you have any queries, you can ask.
No, sir.
सर
Yes, yes.
सर ये सर्किट डायग्राम सर दिखाई नहीं सर स्क्रीन पे.
हाँ
हाँ सर, एक क्वेश्चन इसमें है सर कि
हाँ
हम जो 50 मिली एम्पियर करंट जो जा रहा है सर,
हाँ.
वो सर्किट डायग्राम सर दिखाई नहीं. सर्किट डायग्राम, हाँ
सर्किट डायग्राम दिख रहा
सर 50 मिली, जी जी 50 मिली एम्पियर जो सर करंट जा रहा है,
हाँ
तो
हाँ
स्विच 3 जो 3 नंबर जो स्विच का पोजीशन है,
हाँ.
उसमें तो सर ये 50 मिली एम्पियर तो सीरीज होके निकल जाएगा, इधर से आउटपुट हो जाएगा.
अच्छा, नहीं ऐसा
3
नहीं
नंबर
है.
स्विच पोजी,
हाँ, वही मैं बता रहा हूँ. तो
जी जी
आप इसको कैसे देख सकते हैं वो, अभी R1 है, R2 है, R3 है, ये है, ये है, ये, ठीक है, और ये आपका M है, ये आपका RS है।
जी सर।
तो यहाँ से 50 मिली एम्पियर गया, ठीक है,
जी जी।
यहाँ पे भी 50 मिली
ये
एम्पियर।
एफ एस सर, ये FSD मतलब होता क्या है, जरा बताएंगे?
FSD मतलब जितना मैक्सिमम करंट वो दिखा सकते हैं, जितना मैक्सिमम करंट
मैक्सिमम।
फ्लो हो सकते हैं उससे। तो जो
अच्छा अच्छा अच्छा, उससे ज्यादा नहीं हो सकता है?
उससे ज्यादा नहीं हो सकता, अगर फ्लो जब से ज्यादा चलाओगे तो वो खराब हो जाएगा। हाँ,
अच्छा ठीक है सर, ओके
ठीक है।
सर।
तो 50 मिली
जी सर।
एम्पियर ये RM से चल रहा है। हाँ,
जी।
अभी अभी यहाँ तक 50 मिली एम्पियर आएगा, पर यहाँ से भी अलग करंट आएगा,
हाँ
और
सर, जी सर।
वो करंट ऐसा जाएगा। तो आप जो सोच रहे हैं कि
जी
डायरेक्ट
जी।
50 मिली एम्पियर ऐसा जाएगा, नहीं, वहाँ पे दो करंट आते हैं, वहाँ पे KCL लगाना पड़ेगा, ठीक है।
जी जी, एक नीचे से भी है, एक ऊपर से भी है।
हाँ, तो ये सब पोजीशन के लिए अलग अलग हो जाते हैं। मतलब क्या हो रहा है
जी जी, तो
कि
कहना मेरा ये था सर,
हाँ हाँ हाँ
कहना मेरा ये है सर, कि 50 मिली एम्पियर तो ऊपर से सर चला गया अमीटर के थ्रू, जो
हाँ हाँ
उसके थ्रू।
हाँ हाँ हाँ
लेकिन नीचे में जो सर ये रेजिस्टेंस लगा हुआ है,
हाँ
तो इसमें तीन करंट का रेंज दिया है, 250 मिली एम्पियर, 1250 मिली एम्पियर और 6250 मिली एम्पियर।
हाँ हाँ हाँ,
तो सर ऊपर में जो मीटर का रेजिस्टेंस है वो 1000 ओम है,
हाँ, सही।
1 किलो ओम है। तो सर
हाँ,
नीचे से हम ये तीनों में से कुछ ऐसा लगा सकते हैं अंदाजा कि इतना मिली एम्पियर करंट पास करेगा, चूंकि तीनों पैरेलल होगा तो कम हो जाएगा
नहीं 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 यार,
अगर।
वही मैं बता रहा हूँ। अभी पोजीशन 3 के लिए सर्किट बना दिया हम लोग, ठीक है। उसमें है
जी जी
R1
जी
है,
जी।
उसमें है R2 है, उसमें R3 है, ठीक है।
जी सर।
जब भी आप पोजीशन 2 बनाओगे तो वो ऐसा दिखेगा, ऐसा दिखेगा।
हाँ
हाँ,
सर, हाँ सर, हाँ सर, हाँ सर, हाँ
RM,
सर।
R3, R1, R2, ठीक है।
हाँ हाँ।
और जब भी आप पोजीशन 1 लगाओगे तो RM, R2, R3 एक साथ रहेगा, R1 अलग रहेगा। हाँ,
जी सर, जी सर, जी सर।
तो ये जो जिधर RM है वहां पे 50 मिली एम्पियर करंट ही जा सकते हैं, उससे ज्यादा नहीं जा सकते।
जी, R3 R2 हो करके।
हाँ हाँ हाँ, R2 और R3 की भी सीरीज में है, इसलिए 50 मिली
जी 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 जी
एम्पियर
जी।
से जा रहे हैं। उसका जो
जी सर, जी
पैरेलल
सर।
ब्रांच है उस पे हम लोग को ध्यान देना है, ठीक है। जो पैरेलल
जी
ब्रांच
सर।
पोजीशन 1 में सिर्फ R1 ही है। हाँ, पोजीशन 2
जी
में,
जी जी, पैरेलल में पोजीशन 1 में जो पैरेलल है वो R1 ही है।
हाँ, और पोजीशन 2 में
जी
पैरेलल में R1 + R2 है। हाँ, तो
जी जी जी
रेजिस्टेंस
जी
बढ़ गया।
जी।
और पोजीशन
जी सर।
थ्री में R1 + R2 + R3 हो गया। हाँ, तो
जी
फिर
जी
क्या हो रहा है कि जितना रेजिस्टेंस बढ़ेगा उतना करंट कम जाएगा उसमें।
जी
हम्म,
सर, जितना जितना क्या बोले सर?
जितना रेजिस्टेंस बढ़ता जाएगा वो पैरेलल पाथ में, उतना कम करंट उसमें
हाँ,
फ्लो हो जाएगा।
बिल्कुल सही बात सर, बिल्कुल सही बात।
इसलिए मेरे को मालूम पड़ रहा है कि जो पोजीशन 1
हम्म
है उसमें
हम्म।
सबसे ज्यादा करंट जाएगा। मतलब उसका करंट रेंज 6250 मिली एम्पियर हो जाएगा।
सबसे ज्यादा जाएगा, इसका लॉजिक क्या लगा है सर इसमें?
लॉजिक क्या है कि RM का पैरेलल वाला ब्रांच में, RM जिधर है उसका पैरेलल वाला ब्रांच
जी
में
जी,
रेजिस्टेंस अगर सबसे कम रहेगा फिर मतलब करंट ज्यादा जाएगा। हाँ,
ज्यादा जाएगा, ठीक है सर।
तो पोजीशन 1 में सिर्फ R1 है, पोजीशन 1 में पैरेलल ब्रांच में सिर्फ R1 है, तो उसका
एक
रेजिस्टेंस
एक है
सबसे
सर,
कम है।
R1।
हाँ, R1 है,
ठीक है सर, ठीक, ठीक है सर।
सबसे कम रेजिस्टेंस है, इसलिए उसका करंट सबसे ज्यादा जाना चाहिए।
जी 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 जी, ये हो गया एक नंबर पोजीशन है। दूसरा में सर?
दूसरा में क्या होता है, RM है, RM 50 मिली एम्पियर है, R3 भी है, R3 में भी 50 मिली एम्पियर जाएगा। हाँ,
जी जी
उसका पैरेलल वाला ब्रांच है R1 + R2, तो क्या हो
जी।
गया, उसका रेजिस्टेंस बढ़ गया। अगर रेजिस्टेंस बढ़
हाँ
गया है तो करंट थोड़ा कम होगा, करंट थोड़ा कम
हाँ
होगा मतलब 1250 मिली एम्पियर उसका रेंज होगा,
हाँ।
ठीक है। और पोजीशन
जी
3
सर।
क्या हो रहा है, RM है, RM में 50 मिली एम्पियर ही जाएगा, और उसका जो
जी
पैरेलल वाला ब्रांच में R1 + R2 + R3 तीनों है, तो क्योंकि तीनों
जी।
है उसका रेजिस्टेंस सबसे ज्यादा, तो रेजिस्टेंस सबसे ज्यादा
ओ
रहेगा
आप
तो
इसे, अच्छा।
सबसे कम करंट जाएगा। हम्म,
अच्छा अच्छा अच्छा, ये लॉजिक से आप लगाए सर।
हाँ,
ठीक
ये लॉजिक लगाए, ठीक है।
ठीक है सर, ओके।
ये
ओके सर।
लॉजिक लगाने के बाद हम लोग को मालूम पड़ेगा कि कितना करंट जाएगा। हाँ,
हाँ सर, हाँ सर, हाँ सर, आप समझ गए।
ठीक है।
ओके सर।
So we'll now proceed to solve further questions. Um, तो ये क्वेश्चन में क्या दिया उन लोगों ने, ये क्वेश्चन है, बोले कि वोल्ट मीटर बनाया गया है। एक वोल्ट मीटर है, वोल्ट मीटर हम लोग को यूज करना है, ठीक है। वी हैव टू यूज अ वोल्ट मीटर, दैट इज अ PMMC इंस्ट्रूमेंट। PMMC means it can only measure DC. It can only measure DC. So,
Yes, sir.
okay, that's true. So because it can only measure DC, there, okay, and the voltmeter has a full scale deflection for 10 volt. It can measure 10 volt maximum. Huh? Now I want to measure AC voltage. I want to measure AC voltage with this voltmeter. So what I do is, and when I'm doing that, they use some series resistance diode something. I'm getting the observed voltage is equal to 40%. 40% of maximum means 40% of 10, that is 4 volt. Okay. So this is the logic. So now we will look at how they do it, how it is done. So I have some voltage. Okay, it may be sine wave, square wave, triangle wave, etc. Then I have a diode, and then I have a series resistance. Okay, I have a ideal diode, and I have a series resistance. Okay, so now if the voltage at the input, this input voltage is like this, at this output, okay, what will happen? When this voltage is greater than zero, when this voltage is positive, only then will this diode conduct. Only then is the diode forward biased. And only then you will get this signal. And because the diode, we are considering it as an ideal diode, we are considering the drop to be zero, it will come like this. Then when the voltage becomes negative, the diode will be reverse biased. No drop will be observed. Okay.
Yes, sir.
Then when it is again positive, it is like this, and then further it is zero. Okay, so this is the signal which will come. Okay, this is the signal which will come if there is a sine wave. Suppose we give what is known as a square wave. This is the same circuit. Okay. This is my V in, right? So my V in is like this. Okay. This is A. Magnitude is, suppose let us say the magnitude is A. This is A, then this will be minus A. Okay. And this is my V input. My V output will be given like this. Like this. 0 when it is negative. Again it is positive. Again 0. So this is magnitude is A. This magnitude is also A. So now now this signal V output will go to that PMMC instrument, which will measure the voltage. Okay. So when it measures the voltage, it will measure the average value. To measure the average value of it. So we have to find the average value of this waveform. Okay. So now how will we do that? How will we find the average value? Does anyone have any idea?
Vm by pi, sir.
Vm by pi. Okay. So now in the average, what do you do? when you are finding the average of a signal, let us say that average of the square wave I am doing. Okay, let us see this the time period is t, and this is t by 2. So what I have to do is I have to integrate it. I have to integrate it from time 1 upon t, 0
0 to
to t,
0.
output of t into dt. Okay, this is the standard formula. Now,
Yes, sir.
what is my V output of t? My V output of t is equal to A when t is less than t by 2 and is equal to 0 when t is between, sorry, t by 2 to t to 2. Okay, so this is how
Yes.
my V output of t is. So my average value of my square will be equal to 1 by t. Then I break it down. I make it from 0 to t by 2, it is A into dt, plus from t by 2 to t, it becomes 0 into dt. Okay. Now, this is 1 by t into A into t. The integral A is a constant, comes out, dt integration is becomes t, but the limits are from 0 to t, and 0 is 0, so it becomes 0. 0 to t by 2. Okay. So it becomes 1 by t into A into t by 2. So that's why this t and t get cancelled, and the average value of this square wave is A by 2. Okay. So you must understand that this A is the amplitude. A is the amplitude. Okay, this is the amplitude of your wave. In both your AC wave and in your DC wave, it is the amplitude. A is the amplitude. Right? Now you found out the average value is A by 2. So your PMMC has measured the voltage to be 4 volt. But and it is actually equal to A by 2. So that means your A is actually 8 volt. So using this method, you can tell that this waveform had an amplitude of 8 volt. So without actually measuring this AC quantity, you are only measuring the rectified DC part, and you found that that average value turns out to be 4 volts. You could say that the amplitude of the AC one was 8 volt. Okay. So if you know what is the nature of your input, and then you get the rectify it, and then you get the average of it, then you can tell what is the value. Okay. Gotcha. So now let us try for the next wave. The next wave is in case it is a triangular wave. In case it is a triangular wave of amplitude t. Okay, it's a triangular wave of amplitude t. Then we will again get another wave after the rectification. We will get a wave like this. Okay, so this is 0, this is t by 2, this is t. So now we want to find the average of this, Okay, so what do? We have to find this average of this V output is equal to 1 by t integration 0 to t V output of t into dt. But there is only this triangle is only there. Or and from t by 2 to t it is 0. So we want to find the area of this triangle. Okay, because this is t, and so we have to find the area of this triangle in this integration. So what is that area of this triangle? Can anyone tell what's the formula for area of a triangle?
1 by 2 into base into height.
Yes. So that is, so in this, what is the base?
Base t by 2 हो जाता है 0 से t by 2.
So area of a triangle is half into base into height. So base actually here is t by 2. And what is your height?
जी
Your height
हाइट
is
हो
actually
जाएगा
this
भी जी
A, right? This is
जी ए
A.
हो गया हाइट
जी.
जी
So your average actually this T and 2 get cancelled. So your average V output becomes equal to A by 4. Okay. Now you know what your PMMC instrument has measured that the average V output is equal to 4 volt. That means your A by 4 is equal to 4. This means your A is equal to 16 volt. Okay. Hmm?
ओके सर ओके
Now, if in case the wave was like this, okay, the wave was like this. This is 0, this is T by 2, this is T. Then what is the average value of this wave? Because this is a sine wave. So what is the average value of it? How will we find out? So now they have told that the frequency is 60 hertz. And if you go into the frequency concept, it becomes more complicated. तो मैं क्या करता हूँ इसको ना मैं ऐसे लिखता हूँ ये T है जिधर T T का मतलब 2 पाई जिधर T by 2 का मतलब पाई ठीक है और इसका मैग्नीट्यूड A और ये जो T हो जाएगा थीटा इस तरह भी लिख सकते हैं हाँ
जी सर सेमी सर्कुलर हो गया ना
हाँ ठीक है तो मतलब क्या T T करस्पॉन्ड्स टू 2 पाई और T by 2 करस्पॉन्ड्स टू पाई इसमें इंटीग्रेशन करना मुझे और आसान लगता है इसलिए मैं इस तरह बना रहा हूँ ठीक है अभी ये है V आउटपुट so your V output so your average of V output is equal to ये आपको पूरा टाइम पीरियड वो हुआ 1/2 पाई इंटीग्रेशन ऑफ 0 to पाई में क्या फॉलो करता है A साइन थीटा डी थीटा बाकी का टाइम में पाई टू 2 पाई उसका वैल्यू है 0 इंटू डी थीटा ठीक है तो एवरेज ऑफ वी आउटपुट हुआ 1/2 पाई ए बाहर आया साइन थीटा का इंटीग्रेशन क्या है व्हाट इज
Minus
इंटीग्रेशन
cos
तो दैट इज माइनस
cos
कॉस
थीटा
minus cos.
minus cos theta and the limits are from 0 to pi and plus 0 means it is 0 you can ignore it okay that becomes equal to 1/2 pi into a so what is my this becomes minus cos pi plus cos of 0 so what is cos pi
1, sir.
cos pi is minus
1.
1
Minus 1.
cos pi is actually minus so that becomes
minus 1 1
plus 1 so that becomes equal to a into 2 upon 2 pi that becomes equal to a upon pi. Now they have told us that the average value of V output by the PMMC measured to be 4 volt. That means A upon pi is equal to 4. So your A is equal to 4 pi volts. Okay. So in this way, you can find out.
Okay, sir.
Okay. So, so you're a BTech student or you're a working professional or what are you doing actually? Niranjan?
Yes,
क्या
sir.
बोले सर?
हाँ, तो Niranjan, like, are you a student or you are working or what?
What?
Like, you are studying BTech or what are you doing currently?
क्या सर, आवाज नहीं आ रही?
आवाज नहीं आ रहा है?
वो सुनाई नहीं दी मेरे को।
अच्छा अच्छा, ठीक है। तो और संजीव,
जी सर।
तो आप क्या करते हैं? आप बोले आप काम करते हैं कोई प्लांट में?
जी सर,
सेल में।
बोकारो स्टील प्लांट बताओ।
कौन सा प्लांट में?
बोकारो
स्टील
स्टील प्लांट।
अच्छा अच्छा, ठीक है।
सेल।
ओके, तो फिर आप ये कोर्स तो आप भी इलेक्ट्रिकल में काम करते हैं?
जी सर,
Yes,
जी
sir.
सर।
अच्छा, तो आप क्या क्या इंस्ट्रूमेंट यूज करते हैं वैसे?
सर वहाँ हम लोग ये इंस्ट्रूमेंट तो सर बहुत सारा यूज करते हैं। हम लोग को अमीटर, वोल्ट मीटर ये सब तो है ही, और ये EMPR भी यूज करते हैं, MCCB, MCB, और वेब में नया नया टेक्नोलॉजी सर आया है, तो उसमें भी हम लोग करते हैं।
अच्छा, ओके, तो आप लोग को ये कोर्स पढ़ना पड़ रहा है कि क्या, कैसा हुआ ये कोर्स? आप NPTEL में एनरोल कर दिए?
जी सर,
सर ये
कोर्स आप पढ़ा रहे हैं सर, अच्छा पढ़ा रहे हैं। और ये सर हम लोग इसके बाद बीटेक का जब हो जाएगा तो हम लोग
हाँ,
फिर जो एक्सिक्यूटिव के लिए एलिजिबल हो जाएंगे बहुत बहुत जल्द, और फिर हम लोग एग्जाम दे के ऑफिसर बन सकते हैं। इसी के लिए हम लोग पढ़ रहे हैं।
अच्छा अच्छा, ओके, तो आपका
अभी हम
अभी।
लोग डिप्लोमा करके अभी हम लोग डिप्लोमा करके सर ये काम कर रहे हैं,
अच्छा अच्छा,
और इसके बाद डिग्री मिलने के बाद हम लोग एलिजिबल हो जाएंगे आपका E0 का फॉर्म भरने के लिए, एक्सिक्यूटिव के लिए।
अच्छा, ओके,
इसीलिए सर नाम लिखाना पड़ रहा है।
ओ, तो अभी आप मतलब आप अभी कॉलेजेस बीटेक का कॉलेज में अप्लाई कर दिया कि क्या कर रहे हो अभी? कि अभी
तो
आप
सर हम एडमिशन ले लिए हैं आपका ये बोकारो में है एक गुरु गोविंद सिंह एजुकेशनल सोसाइटी एंड टेक्निकल कैंपस,
अच्छा, ओके,
इसमें एडमिशन ले चुके हैं 3rd सेमेस्टर में, डायरेक्ट 2nd ईयर में।
हाँ हाँ, डायरेक्ट, क्योंकि आपने डिप्लोमा कर दिया तो डायरेक्ट सेकेंड ईयर में जाएंगे, हाँ, ओके।
जी 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 जी।
सर 4th सेम का तो ये है सर, कोर्स है
लेकिन
ये।
लेकिन सर अभी तक 3rd सेमेस्टर का एग्जाम नहीं हुआ है।
ओह, इतना लेट?
और 4th सेमेस्टर का तैयारी करना पड़ रहा है।
अच्छा अच्छा, नहीं, अभी तो आपका सेकेंड ईयर ही पूरा खत्म होना चाहिए ना, आपने एडमिशन कब लिया?
एडमिशन सर पिछले साल सितंबर में लिए हैं, 23 में।
हाँ, तो पूरा सेकेंड ईयर होना चाहिए, खत्म
हाँ सर,
हुआ
अभी
होना
नहीं
चाहिए।
हुआ है।
क्यों, क्या प्रॉब्लम हुआ वैसे?
क्या सर?
क्या प्रॉब्लम हुआ कि आपका नहीं हुआ? मतलब वो कॉलेज डिले कर रहा
वो
है पूरा
सर
कि क्या?
सर इसी साल से जो है ना, वर्किंग प्रोफेशनल के लिए
हाँ
ये
हाँ
2023 में ही परमिशन मिला है,
हाँ हाँ,
AICT के थ्रू।
ओके ओके,
तो
अच्छा,
सर जो उसको तो मिल गया, परमिशन तो मिल गया एडमिशन लेने के लिए।
हाँ
लेकिन
हाँ
बीच में जो टेक्निकल प्रॉब्लम है, जैसे एग्जाम कैसे अटेंड लेना है, या
हाँ
फिर
हाँ,
कैसे उसका पढ़ाई कैसे होगा, फिर असाइनमेंट लिखना है, प्रैक्टिकल होना है, कैसे कैसे होगा, इसी सब प्रोसेस में ना डिले हुआ है सर।
अच्छा अच्छा, तो मतलब आपको कॉलेज जाना पड़ता है कि नहीं जाना पड़ता है?
जी सर, इवनिंग क्लास करना पड़ता है।
आज ऑनलाइन होता है कि आपको कॉलेज में जाके करना पड़ता है क्लास?
जी, कॉलेज जाके करना पड़ता है सर। ये 6 से 8 बजे तक था, लेकिन हम लोग का सिलेबस लगभग कंप्लीट हो गया है 3rd सेमेस्टर के लिए।
अच्छा, तो आपका क्लास
तो
रात को होता है?
इसीलिए जी सर।
आपका क्लास रात को होता है क्या?
हाँ, इवनिंग क्लास सर, 6 से 8।
ओके, अच्छा, तो आपका कौन सा सब्जेक्ट है वैसे?
हम लोग इलेक्ट्रिकल में है सर, 3rd सेमेस्टर में ये नेटवर्क थ्योरी हो गया, इलेक्ट्रिकल मशीन हो गया, EMFT हो गया,
ओके,
और सर ये मैथ हो गया, इंजीनियरिंग मैथ,
ईवीएस।
इलेक्ट्रॉन इलेक्ट्रॉनिक्स हो गया, और
ईवीएस।
इलेक्ट्रॉनिक्स हो गया। जी सर, ये
अच्छा अच्छा,
6 सब्जेक्ट है।
ठीक है ठीक है। एक्चुअली मेरा आपको ये ड्राइव लिंक और यूट्यूब लिंक मिल गया?
जी सर।
ये मैं भेज देता हूँ। तो एक मिनट, चैट में मैं डाल देता हूँ।
जी
तो
सर।
ड्राइव लिंक में आपको जिधर ये मैं नोट्स मीटिंग के बाद मैं ये नोट्स अपलोड करूंगा, यूट्यूब वीडियो भी
जी
अपलोड
जी
करूंगा, तो मेरा चैनल में आपको मिल जाएगा। ठीक है। और मैंने
जी सर, मेरा जीमेल में। जी।
हाँ
मेरा सर ये जीमेल में अगर आप अपना लिंक भेज दीजिएगा ना तो सर, तो हम कर लेंगे बढ़िया से।
नहीं नहीं आप
यूट्यूब में सर आप चैनल देखे हैं सर इसी में।
हाँ,
नहीं तो ग्रुप में भी डाल दीजिए ना सर।
कौन सा ग्रुप?
ग्रुप में डाल दीजिए ना।
नहीं पर मैं ग्रुप में नहीं हूँ ना।
जी सर। जी सर।
हाँ। और एक बात है कि आपको नेटवर्क एनालिसिस पढ़ना है, तो मैंने भी नेटवर्क एनालिसिस पढ़ाया था लास्ट ईयर, मतलब
जी
लास्ट सेमेस्टर 2 बार मैं पढ़ाया हूँ, तो
जी
दोनों का रिकॉर्डिंग सब है। हाँ, अब आपने
जी जी।
वो यूट्यूब
हम
में
तो सर ये फर्स्ट वीक वाला जो असाइनमेंट था वो भी सर सेंड किए थे अपने से बना करके, जो आपको पढ़ाए उसको समझ करके, तो उसमें कितना सही कितना गलत हुआ वो तो हमको खुद पता नहीं चल रहा है।
ओ, क्यों क्यों क्यों?
फर्स्ट वीक का जो है ना असाइनमेंट,
हाँ हाँ हाँ
वो सर हम सेंड कर दिए, सबमिट कर दिए हैं।
हाँ हाँ हाँ।
तो उसमें कितना को सही हुआ कितना गलत हुआ ये पता चले, तब तो हमको अपना अपना लेवल पता चलेगा कि हम कितना लेवल में है।
ओ अच्छा। हम्म, वो भी बात है, सही बात। लोग ने सोल्यूशन लोग भेज देंगे, मतलब शायद से 1 या 2 हफ्ता बाद लोग सोल्यूशन भेज देंगे, फिर आपको मालूम पड़ेगा कि ये आपने राइट सॉल्व किया
जी
कि
सर। जी
ऐसे।
जी 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 जी
हम्म।
सर।
और और क्या है, आपको कुछ फीडबैक है कि क्या कैसे में पढ़ाना चाहिए, वैसे कुछ?
सर आपका ये जो ये पढ़ा रहे हैं वो इलेक्ट्रिकल मेजरमेंट और इंस्ट्रूमेंट सर,
हाँ
ये सब्जेक्ट भी बहुत बढ़िया पढ़ा रहे हैं, और एनालॉग इलेक्ट्रॉनिक सर्किट जो भी पढ़ा रहे हैं सर वो भी बढ़िया पढ़ा रहे हैं। इसमें सर है क्या कि कभी कभी होता है कि आप दोनों सब्जेक्ट का एक ही टाइम हो जाता है।
हाँ हाँ।
तो उसमें सर हमको कोई एक ही सब्जेक्ट पढ़ना पड़ता है, तो एक सब्जेक्ट छूट गया। तो थोड़ा सर यही है कि आपस में कंप्रोमाइज करके कभी टाइम को आगे पीछे कर दिया जाए, तो हम लोग दोनों क्लास अटेंड कर लेंगे।
नहीं नहीं, वो एनालॉग इलेक्ट्रॉनिक्स का भी होता है?
जी सर।
वो जो दूसरा सब्जेक्ट का टाइमिंग क्या है?
सर पिछले सप्ताह में जो 27 या 28 तारीख को हुआ था क्लास, उसमें
हाँ।
सर उसी दिन 6 से 8 बजे तक शाम में क्लास हुआ था।
ओके ओके।
तो
अच्छा
हमको कोई एक सब्जेक्ट ही हमको पढ़ना पड़ा, एक सब्जेक्ट मेरा छूट गया एनालॉग सर्किट, ये आपका क्लास किए, सर का
हाँ।
क्लास छूट गया उधर।
अच्छा, तो भी ये दोनों क्लास
तो
वो
एक
रिकॉर्ड हो जाएगा ना? रिकॉर्ड होके आपको यूट्यूब वीडियो मिल जाएगा ना?
वो तो सर रिकॉर्डिंग मिल जाएगा, लेकिन जो जोश रहता है सर, जो वो तो
हाँ
सर फिर कम हो जाता है ना।
हाँ
उमंग
हाँ
जो होता है कि क्लास करना है, वो
हाँ।
कम हो
ओके,
जाता है।
वही वही।
जैसे हम आपसे अभी सवाल पूछ लिए, हमको प्रॉब्लम
हाँ
हुआ तो हम पूछ लिए,
हाँ हाँ हाँ
लेकिन आप उसमें तो नहीं पूछ पाएंगे जो आप
हाँ।
भेजेंगे भेजेंगे सर।
वो बात है। हम्म,
इसीलिए बस आप।
अच्छा। और पर हम लोग का टाइमिंग मतलब फिक्स कर दिया, क्योंकि हम लोग का भी काम के हिसाब से हम लोग ने टाइम डाल दिया वही। तो
जी सर।
मंडे मेरा टाइमिंग तो सोमवार को 6 से 8 है। सिर्फ ये
जी
हफ्ता
सर। तो
बस
अगर
प्रॉब्लम था, नेक्स्ट वीक प्रॉब्लम था कि मैं बाहर जा रहा हूँ, तो इसलिए मैं
हाँ हाँ सर, कोई बात
थोड़ा
नहीं।
आगे कर दिया।
कभी
वही।
कभी सर आगे पीछे सब्जेक्ट हो जाएगा ना टाइम, तो हम लोग को दिक्कत नहीं होगी सर।
ठीक है ठीक है। ओके। अच्छा।
हम तो इस संबंधित हम मैसेज भी किए थे, जो एनपीटीएल का जो ये ऑफिस है,
हाँ हाँ हाँ
उसमें हम मैसेज भी किए थे इससे संबंधित, तो
हाँ।
उधर से कोई रिस्पॉन्स नहीं मिला,
ओ
कोई फीडबैक नहीं मिला।
अच्छा, उन लोग के लिए मुश्किल रहेगा, क्योंकि सब लोग जो उन लोग का टाइम के हिसाब से डाल दिया, तो
जी। तो एक्चुअल में हम तो स्टूडेंट है ना, हम लोग को दो सब्जेक्ट एक टाइम में तो नहीं ना पढ़ सकते हैं सर।
हाँ हाँ हाँ, वही वही, वही बात है।
हम तो
वही।
कोई एक सब्जेक्ट ही फॉलो करेंगे।
ओके। हाँ। अच्छा, तो आपको और कुछ डाउट्स है क्या?
नहीं सर, अब डाउट्स नहीं है, और डाउट्स होगा फिर तो सर हम आपसे पूछ लेंगे।
हाँ, नेक्स्ट नेक्स्ट वीक मतलब 2 हफ्ते बाद तभी हम लोग लेंगे, तभी आप पूछ सकते हैं,
जी
ठीक है?
सर।
ओके, तो ये जो भी
ठीक
नोट्स है मैं अपलोड कर दूंगा यूट्यूब मतलब ड्राइव पे, और यूट्यूब वीडियो भी
जी
अपलोड
सर।
होगा, तो आप उसको रेफर कर सकते हैं, ठीक है?
ओके सर, ओके सर।
फिर हम लोग एंड कर देंगे।
ठीक है सर।
हाँ, ठीक
ओके
है,
सर।
थैंक यू।
जी सर। थैंक यू सर, नमस्कार।
बाय।